are going to study in depth semiconductor strain gauge and strain gauge in a Wheatstone bridge and temperature compensation for the strain gauge. Okay, so the last 2 points we people are going to see thoroughly. So here semiconductor strain gauge is the point which we people are going to discuss. What is semiconductor strain? It is similar to that of a resistive type of strain gauge. Then what is the change when it is similar to that of resistive type of strain gauge, or it operates similar to that of the resistive type of strain gauge? It is having some of the changes with respect to that of construction and property. So the gauge factor for the semiconductor strain gauge is much higher compared to that of metal strain gauge, and that is the advantage, as I have specified, that the gauge factor lambda which we people are supposed to be interested in that particular term, that lambda should be higher one, and in semiconductor strain gauge the gauge factor is much more higher compared to that of your metal type of strain gauge. But here the change in conductivity due to the strain is much larger than the metal. So what is that? Conductivity, electron based. Semiconductor means it is based upon the electron base, and how it is, we people are going to see that particular aspect. So depending upon the conductivity, actually there will be a change, or much larger change will take place compared to that of metal type of strain gauge. Okay, it is typically smaller than the metal type of strain gauge. Means here for the compact application also you people can commonly use a semiconductor type of strain gauge more often, or sensitivity to the temperature variation. This is the main limitation of this semiconductor strain gauge. Why this is so? The reason is that if suppose I am having a strain gauge with me, this strain gauge, semiconductor strain gauge, if this strain gauge is coming across the variation in the temperature at that particular instant, if my temperature increases or if my temperature decreases, no doubt when we people are saying that it is semiconductor strain gauge, it is associated with the atoms and electrons, and these electrons or the atoms, actually when variation in the temperature takes place, uh, at that time there will be variation in its register. However, I would like to highlight or focus on the point that when we people are coming across any temperature sensitive region, temperature sensitive area, or across a temperature, the resistance is having, or the temperature sensitive resistance is having a significance or a property. I would like to say a property. As temperature increases, its resistance will also increase, or its resistance will also decrease. It depends upon positive temperature coefficient or negative temperature coefficient. It means that positive temperature coefficient means when temperature rises, increases, at that time your resistance will increase, and when temperature decreases, at that when temperature increases, at that time your resistance decreases. That means it is negative temperature coefficient, means reverse output you people are getting. And for semiconductor strain gauge, here in this aspect, actually this is sensitive to your temperature variation. It means this is the limitation. And to overcome this limitation, there is a need of temperature compensation. What does it mean? Temperature compensation means you are trying to resolve the problem that is arising due to the variation in the temperature. It means the environmental or the surrounding temperature across the strain gauge, if there is a variation in the temperature increase or decrease, your strain gauge should not vary its resistance. That is the compensation. You are trying to compensate that strain gauge for the environmental condition. So in semiconductor strain gauge, the limitation is that it is sensitive to variation in the temperature. To overcome that problem, compensation is necessary. Okay, so we are going to see the temperature compensation also, so that the variation in the temperature is not going to affect the resultant output due to the variation in the environmental condition. All semiconductor material exhibits changes in resistance due to the strain. Okay, so most commonly strain gauge material used is the silicon. Why this is so? It have the inert property and easy of the production. So this is having the inert property and it is easy for the production purpose. That's why silicon is commonly used device to design a semiconductor strain. Now, as in the previous case also, we people are using a base material because strain gauge is nothing but it is a filament. So if suppose I have considered a strain gauge, suppose this is the strain gauge. This is one of the filament of a lightweight. This may fall down. This may fall down. So what is our requirement? Our requirement is that this particular material, this particular material should be, this particular material should be actually have some support. Okay, this particular material should have some support. Okay, so this is nothing but this external part is the support on which this filament is mounted so that it will hold the condition. So what type of material is to be used? The base material is doped. This is your base material. Is doped by a diffusion of boron or arsenide for P or N type to obtain a base resistance as a needed. For a base material as a needed base, that is means on some base. Suppose table is the base, to place a duster, to place a coarse file, to place a chalk or place anything. Bench is the base for you people, whether to sit, then place your notebooks, place your bag to write. That is the supporting. Base means the supporting that you people are having. Okay, the substrate provide the mean of a straining the silicon chip. Silicon chip means actual, that is the semiconductor material, and connections are provided by deposition of the metal at the end of the device. Means you are not using the entire foil. You are not using the entire foil. However, you people are trying to provide some connection. So this is the length which I have specified. Here I will use the different color. Okay, white color is not. This is the length. Okay, these are nothing but these are some of the means across where you people are trying to take the resultant output. Means you are not making the connection across the entire region. Different parts are specified. But when we people are applying a force, this is the length. This length is going to be changed. And this has been placed on this particular substrate. This has been placed on this particular substrate. Okay. So the substrate provides the mean of a straining the silicon chip, and the connections are provided by deposition of the metal at the end of the device. So the construction has been represented in the figure below for the semiconductor strain gauge. Okay. Now different types or other type of strain gauges. If you try to visualize, this is the substrate. Inside this one, we people are having the strain gauge. These are the connections. Over here, these are the connections. Different type of strain gauges. This is C type. Here are the strain gauges. On this particular metal, you people are connecting wire. These are the coiled type. These are the connections. These are the four in angle represented. This is the plus one. This is the square one. What are these? Depending upon application, if you people are interested to measure the strain of the different regions, at that time you can use these different types of strain gauges. Okay, these different type of strain gauges. Now, how this is so? If C type, I am interested to measure the strain gauges for the C type. At that time, I can use C type. For the large portion, I can use this particular aspect. If I am interested to measure the center one, I can use this one. If for the square aspect, we can use. So these are the for different applications. Only I want to show in this aspect is these connections that are used. Two wires are removed externally, and that we people are trying to connect across the Wheatstone bridge, and these strain gauges are mounted where you people are interested to measure